Okay, so welcome guys to another session on Laplace transformation. So on our last video we learned how to calculate the Laplace for the cosine of 80, which is equal to s divided by x squared plus 80. So if you haven't seen the last video which I did, please I advise you to go and watch it before you proceed, before you come to this video I'm about to make. So we treated on the last video the Laplace of the Laplace of the cos function of 80, which is equal to x divided by s squared, and we treated few examples on how to calculate it. So I advise you to go watch this one. Go back to my last video, my playlist Laplace transformation, then you see other videos I did. So today we are going to be looking at the Laplace of hyperbolic functions of sine and cosine. So today for the first one we are going to be looking at the Laplace of sine function, which is a hyperbolic function. So we're going to be treating how to calculate the formula for the Laplace of sine function. So today we are going to be treating the Laplace of sine 80. Now this is basically called a hyperbolic function. So now basically we all know that sine, which is a hyperbolic function, if you really remember hyperbolic function, how they represented hyperbolic function based on exponentials. So the sine of 80 based on hyperbolic function is equal to sine 80 is equal to 1 divided by 2 open bracket exponential 80 minus exponential minus 80. So this is basically the representation of sine 80 based on hyperbolic function is 1 over 2 open bracket exponential 80 minus exponential minus 80. So this is basically a standard, it's a constant, it's a standard representation. It's not that actually you are asking, where did you get this from? No, this is a standard, although it's been derived, but this is a standard representation. Sine of 80, just like me saying sine is equal to opposite over adjacent, just like sine 80 is equal to 1 over 2 open bracket exponential 80 minus exponential minus 80. So with this representation, this is exactly what we are going to be using to find the Laplace of sine 80. Now, if you can also remember, I've been revisiting and I've been trying to keep you in touch with the standard formula for the Laplace expression of any function of t. So the Laplace, remember the Laplace of the function of t is equal to what? The integral starting from 0 to infinity, right? Of the function of t times exponential minus st dt. So we are also going to make following the same representation to calculate the Laplace of sine 80. So basically the Laplace of sine 80 is equal to integral from 0 to infinity, right? Now the function of t here is what? Sine 80 times exponential minus st dt. Now we all know that sine 80 is equal to 1 over 2 open bracket exponential 80 minus exponential minus 80. So we're going to be substituting this, replacing it with sine 80. So this is equal to integral starts from 0 to infinity open bracket 1 over 2 open bracket exponential 80 minus exponential minus 80 times exponential minus st dt. So this makes it very, very easy for us to actually integrate it and apply our limit. So guys, based on continuing from where we stopped, so we said, this integral starts from 0 to infinity, 1 over 2 open bracket exponential 80 minus exponential minus 80 times exponential minus st. So this right here, remember, is actually the representation of sine 80. So we actually substituted sine 80 for this right here. So we actually replaced it for it. So this makes it very easy for us to integrate. So before we apply our limit, we have to integrate it, right? So integrating this, let's take out the constants. We'll be having 1 over 2 integral exponential 80 minus exponential minus 80 close bracket exponential minus st dt, right? So Now integrating this, first one integrated. Now let's multiply through by, let's multiply exponential minus st through. So multiplying it through, we'll be having 1 over 2 integral exponential at times exponential minus st minus exponential minus at times exponential minus st, or respect to t. Right? So now we all know that the exponential of m times the exponential of n is equal to the exponential of n plus n. That's the rule for the rule for exponential, which says the exponential of m times the exponential of n is equal to the exponential of n plus n. Right? So this same rule we are going to be applying here. So applying it, we be having, so exponential of at times the exponential of minus st is equal to what? So 1 over 2 integral, this becomes exponential of at, since there's minus x, so it's plus and minus is minus, so at minus st minus exponential of minus at plus, sorry, exponential of minus at times exponential of minus st. This gives me equal to exponential of minus at plus minus st, which is more plus and minus is also minus, so this is exponential minus at minus st. So we are going to simplify this, right, before we integrate. So at minus st, right? So if I factor out minus sign, that let me just rearrange it. Put s here and put a here. So let me just rearrange. So this is what I have: 1 over 2 integral. Taking s, we are having minus st plus at, right? This is what I have. I'm actually just putting s here and putting a to the other side. So minus exponential, it's doing the same thing here also. We're having minus st minus at, right? Open bracket dt. Right? So I'm going to factor in out the minus sign so we can easily integrate it. So it will be very easy for us to integrate. So continue from where we stop, right? We have 1 over 2. So now we can factor out the minus sign up here. We're having integral exponential minus open bracket s minus a. Remember, if I factor out the minus sign out from this, so this becomes minus, right? So I'm factoring out t also. So we have t here. Minus exponential. Factoring out the minus sign, you have minus x plus a. Then factoring out t out also, we have t dt. So now we can integrate this. So integrating this, will be having 1 over 2 integral exponential minus s open bracket a respect to t with respect to dt, right? Minus integral exponential minus open bracket x plus a dt. So integrating this one, will be having 1 over 2 exponential minus s minus a divided by s minus a, right? Minus, integrating this one also, will be having exponential minus s plus a divided by minus s plus a. So now, what's our next step? Okay, minus will cancel minus, right? So we'll be having 1 over 2 open bracket exponential minus s minus a divided by minus s minus a. And you have plus exponential minus s plus a divided by minus s plus a. Sorry, s plus a. So now we successfully integrated this factor. So what's our next step? Remember, our limit says the integral from 0 to infinity of sine at t, right? So we are taking the limit from 0 to infinity. So our next step now is to take our limit from 0 to infinity. So now let's proceed. So applying my limits from 0 to infinity, right? So this becomes limit t into infinity, right? Of this, right? So this is 1 over 2 open bracket exponential minus s minus. Now this constant will eventually be multiplied all through of them, so I can factor out the constants 1 over 2 here. Exponential minus a t divided by minus s minus a, right? Plus exponential minus s plus a divided by s plus a minus taking another limit to 0, right? Taking my limit to 0. So this is limit to 0, open bracket, exponential minus a t divided by s minus a plus exponential minus s plus a divided by s plus a. So taking t to infinity, applying t to infinity, this infinity eventually multiplies all through and everything becomes 0, right? This same thing goes for this place too. Everything becomes 0. So when t tends to infinity, all this becomes 0. So we have in 1 over 2, open bracket, 0 minus, now limit when t tends to 0. So when I put 0 here, 0 times s minus a eventually becomes 0. So the exponential of 0 is 1. So I'm having exponential 0 divided by minus s minus a, right, plus limit of this also, remember there's t here, so limit of this, so this is 0, right? 0 times this eventually becomes 0, so this is plus exponential 0 divided by s plus a. So this is equal to 1 over 2, open bracket, 0 minus this eventually becomes 0, minus times minus is plus, so minus is multiplying through, right? So this is exponential 0 divided by s minus a minus exponential 0 divided by s plus a. Exponential 0 is what? 1, right? So we'll be having 1 over 2, open bracket, 1 divided by s minus a minus 1 divided by s plus a. So this makes it easy for us to simplify. So all we have to do is to simplify that and we get our answer. So like I said, simplifying this, all we have to do now is to simplify this to get our answer. So now let's simplify. So we'll be having 1 divided by 2, open bracket. Taking the LCM of this, we'll be having s minus a, s plus a. S in s minus a, that's s plus a, right? Plus, sorry, is that plus or minus? Sorry, when minus multiplies with this was plus. This was plus. So s minus a and s plus a will be having s minus a, right? So multiplying through, we'll be having 1 over 2, open bracket, s plus a minus s plus a divided by s minus a times s plus a. So this will cancel this, right? So we are left with just a. So a plus a is 2a, right? So we are having 1 over 2, open bracket, 2a divided by s minus a and s plus a. So basically we all know that this is actually sum of two squares, right? Sorry, this is actually the difference of two squares. So s minus a times s plus a, when we expand it, we'll be having 1 over 2, open bracket, 2a divided by s squared minus a squared. So you can expand it and see you actually have x squared minus a squared. So we don't know that 2 cancel 2, right? So this gives me our final answer is equal to a divided by x squared minus a squared. So we can say that the Laplace of sin at, which is equal to the integral of 0 from 0 to infinity of sin at times exponential minus st dt is equal to a divided by x squared minus a squared. So the Laplace of sin at is equal to a divided by x squared minus a squared. Now do not interchange, do not misconfuse it for the Laplace of sin at. Laplace of sin at is a divided by x squared plus a squared. But the Laplace of sin at is equal to a divided by x squared minus a squared. So now let's take an example. So after all we've calculated our final answer, the Laplace of the sin of 80 is equal to a divided by x squared minus a squared. So now we're going to take an example. So for instance, we said find the Laplace of sin 5t. Now we all know that the Laplace of sin 80 is equal to a divided by x squared minus a squared, right? So definitely the Laplace of shine 80, comparing this to this, we know that my A is equal to what? My A is equal to 5, right? So A is equal to 5. So definitely Laplace of shine 80, which is equal to A divided by x squared minus A squared, is equal to Laplace of shine 5t will now be equal to 5 divided by x squared minus 5 squared, which is equal to 5 divided by x squared minus 25. So we're going to drop one exercise for you to practice through, then go to our next section of the video, which is to find the Laplace of cos 80. So an exercise for you goes, find the Laplace of sine 60. So this one says find the Laplace of sine 60. So this is what you can use to practice through. Then our next video is going to be, our next section is going to be Laplace of cos 80. So see you on the next one.